source. And next to a question that, I have to be honest, I haven't asked myself before, but I'm told by the BBC Science Unit that fish can see optical illusions. Now we've been looking into this, it's a pretty interesting area. On the web, our science unit have put up a number of different optical illusions to help us understand how this works with our brain. For instance, which of those three squares do you think are bigger? Or if we take another example, does that appear static or does that seem to be moving to you? And then one last question, which of those two red circles seem bigger or smaller to you? Let's go and speak to Melissa Hogenboom about this. So I have to say, fish, optical illusions, it hasn't been on my agenda before, but what's this telling us more broadly about how our brains work?
Well, it shows that, like fish, we need to navigate the complex world in which we live. We need to see how far away objects are, whether they're moving, and we have the same challenges that fish do. When something's moving really fast towards us, we need to know. Our evolutionary ancestors needed to get away from people hunting them, for example. And it's nice that fish see them too. It shows that it's the same process.
So, for instance, with the example of the red dot here, what is happening to our brains that makes us think that the red one on the right is smaller?
This is a classical illusion called the Ebbinghaus, and it shows that context is really important to how we see the world. When you see someone who's really far away, the physical property on our retina is the same, but we instinctively know that they're actually far away. And so when you surround an object with a small object with a bigger one, we instinctively see that middle object as smaller. So it just shows that the shortcuts we make in the real world, when applied to illusions, trick us, but actually it's a really useful process we have.
It's all very interesting. Is there a purpose to understanding this? Can we do something with our understanding of what's happening when we look at these things?
Yeah, of course. When you see the difference between how we perceive the world and how we actually do, it allows scientists to understand how our vision works. So it's really important because we need to know the neural processes involved behind vision. And when they look at illusions, when they put someone in a brain scanner and see that, the moving snakes illusion, it's called the rotating snakes, they actually see that neurons respond to movement in the same way as they do when they look at this static image, even though it's not moving at all.
I have to say, the one that our viewers are looking at the moment, which it's not, everyone else is saying it's moving, but it's not moving for me. Does that mean that
it's not moving?
Maybe I'm part fish or something? I don't know. What's going on there?
Well, it's apparently to do with whenever we look at the world, our eyes are constantly making small movements. So every time our eyes make a movement, our retinal image is refreshed. So maybe your eyes are quite static, right, but usually we're always darting around the place.
All right, good to speak to you, Melissa. Thank you very much indeed. That's Melissa Hogenboom, and you can see the interactive feature that Melissa and her colleagues have produced on that story through bbc.com/